Okay, so we're going to talk about the molecular mechanics of imagination. So basically, how imagination works on a cellular level. Alright, so what we're going to talk about first is the theory of cell assembly. And I say theory because it's still widely speculated on how imagination works. So everything I'm going to talk about in this video is basically all theoretical, and what scientists believe as of now, as of the research that they've conducted, is believed to contribute to imagination. Alright, so cell assembly basically works starting with perception. And so once a real world object is seen, neurons form the mental image in your mind, and then these neurons will be able to come together again without seeing the real world object to form the picture in your mind, and that's known as imagination. So what it's saying is, when you see an object, any object that will be stored in long-term memory, there will be certain neurons designated to collect and form this certain image that will be called upon again when you decide that you want to think of this object at a later point. Okay, so next we're going to talk about the role of memory, which is sort of referred to in the last slide with perception. So remembering the past has a significant link to imagining the future. And that's really what we're going to talk about for the rest of this video. And so a lot of the procedures that neurons go through to recall past memories also can be linked to the processes that the brain undergoes to imagine things and to go through creativity and imagination. And as much as we'd like to think that our ideas pop out of thin air, they're really based off of our past experiences. And as of research that has been done to this day, the research has shown that understanding how we remember the past helps us to understand and better achieve a more imaginative future. Studies from Addis and other notable scientists of the time have shown that the medial temporal and frontal lobes, posterior cingulate and retrosplenial cortex, and the lateral parietal and temporal areas all are engaged when imagination is thought of, or imagination, the process is carried out in the brain. Therefore, it's believed that this general neural network, which is known to the science world and to the medical world as the default network, is engaged in a similar way for both remembering and imagining things. But though they do bring about striking similarities, like them both being involved in the default network and the neural processes that they undergo, they do have a lot of important differences that we're going to talk about right now. Alright, so right now we're just going to go over a few of the characteristics that only apply to the brain processes of imagination. Okay, so the ones I mentioned earlier, the parts of the brain that I mentioned earlier were used both in memory and in imagination. So there are a few brain regions that are used strictly for imagination, and those are the frontopolar regions and the hippocampus, and the hippocampus especially. And they're both engaged in imagination, and to a greater degree than they are in memory. And the increased hippocampal activation for imagining future events usually can be explained by the fact that imagining future events requires the generation of new mental representations, which results in a greater degree of encoding than for previously stored information. So this flexibility of recombination is what brings in the hippocampus and what makes imagination a little bit different, because with memory you recall events exactly how they happened, and it's basically already in the imagination through which is theoretical, but through the cell assembly, which is what is the most common belief at the moment. And so with imagination, you have that flexibility. You create a new mental representation of the through your imagination, through what you are creating in your mind, and so that definitely changes it up from memory. And then the last evidence that shows the difference between, brings in the. Okay, so we're going to talk about some of the characteristics that only apply to the brain processes of imagination. Okay, so first off, we're going to talk about the different brain regions that are activated. Now, earlier I talked about some of the brain regions that are activated, but that occurs in both the memory processes and the imagination processes. Some of the regions that are activated as well are the frontopolar regions and the hippocampus. And the hippocampus is especially significant because it allows us to call upon the short-term and long-term memory and pull chunks from the past to form new images of the future. And that requires a greater degree of encoding than that for previously stored information. And that brings me to my next point, which is the flexibility of recombination, which is basically what I just said, how you can pull from different past experiences and form new imagined ones. And so you pull from the past representations that you've experienced to sort of build up this this new image. Think of it as Legos. Your imagination allows you to pull different pieces from different events and stack them up to form in various different combinations to form some new idea. Okay, so another significant point being made by scientists and researchers of today is the evidence that can be found in memory loss patients. So there's been studies conducted in Alzheimer's patients, dementia patients, and what they do is they ask them to recall past events and combine it into some form of an imaginative scenario or place or action. And then they'll compare this autobiographical memory task to a strictly constructed experience task. And what they found was that people who had diseases that impaired their memory were definitely impaired when they were asked to imagine things, but they were able to imagine things and still had a somewhat developed imagination, even though their memory had been failing them. And I think this is pretty significant in seeing the difference between, or the distinction that can be made between memory and imagination. Though they are similar and the brain processes at a cellular level are pretty similar, there are differences and they can be separated.